In this lesson, we'll cover how phase rotation works in an IQ8 commercial system. After completing this lesson, you should be able to identify circuit layout constraints due to phase balancing, know how far out of balance is acceptable, and know how QD cabling achieves phase balancing. Phase rotation and phase balancing is a product of the QD cable. The microinverters produce at a single phase 208, and the QD cable alternates that 208 current over 3 lines. QD cable has power on 2 phases and sensing on the other phase and neutral for phase loss sensing. This arrangement alternates between phases for each drop to achieve self-phase balancing. The QD 4-pin male connectors plug directly into the microinverters, whose double insulated rating requires no ground conductors. This means that you don't have to do phase balancing in a load center with breakers. It's done for you by the QD cable. This diagram shows you how phase balancing is achieved using QD cable rotation. Similar methodology can be used for any system size. The microinverters are exporting power through pin 1 and 2 on the microinverter. Pin 3 and pin 4 are used for sensing. Notice how the QD cable puts the first inverter's power on line 1 and line 2. The plug after that puts power on line 2 and 3, and the third in the sequence on 3 and 1. That makes an equal amount of power go over all 3 phases, even though it's a single-phase microinverter. An important thing to remember is that if you have to cut QD cable to end a row, always start the next series of modules by plugging into the next drop after the cut end. Notice that in this diagram I had to stop on drop number 9, so the next sequence of microinverters should start with number 10 to keep the phases balanced. Also, notice how the system depicted in this diagram has an amount of microinverters that are not divisible by 3. If the amount of microinverters in the system are not in multiples of 3, then the number of micros across each phase may differ by a maximum of 1 for phase connection. So we have 14 micros on line 1 and 2, 14 on 2 and 3, and 13 on 1 and 3. Please refer to local AHJ and utility rules for acceptable phase imbalance across the system. When you're using your QD cable, it's important not to plug in the center tap into an inverter because it connects to line 1 and 2. You will wind up with one extra inverter connected to lines 1 and 2. It will effectively look like this. It will be out of balance because you will have one additional microinverter connected to lines 1 and 2.